Right, children, now we are in the second question of 2023 paper, which has the smallest ionic radius. So what they are asked to find is ionic radius. You want to pay attention for this one. What I want to find ionic radius. From the periodic table, we can find atomic radius. But here what they ask, ionic radius. Ionic radius is governed by the charges, right? Now for an example, concern there is a 3 plus charge and 3 electron. So what is the charge of the nucleus? Plus 3. And how many electrons there? 3 electrons. And what is the charge of the nucleus here? Plus 5. But how many electrons there? 3 electrons. Right? So here plus 3, 3 electron, plus 5, 3 electrons. So these 3 electrons are attracted by plus 3 charge. These 3 electrons are attracted by plus 5 charge. So which one has a greater attraction? Same number of electrons here and here, same number of electrons here and here, but this one has a greater attraction because more protons are there. So therefore finally what happens? This electron cloud little shift towards the nucleus, but this cloud of electron more shift towards the nucleus. So the ultimate result is this one makes a bigger ion and this ion is smaller because it has more charge. So you can understand that higher the protons, more the attraction, so smaller the size of the ion glass. Okay, with the same point I come to here. Now we are talking about these chemical species: fluoride, magnesium, sodium and oxide. Fluoride, how many protons? 9. Magnesium, how many protons? 12. Sodium, how many protons? 11. Oxygen, how many protons? 8. That they all have how many electrons? Fluorine has 9 electrons. Fluoride means 1 electron gain, so 10 electrons. Magnesium has 12 protons, that means 12 electrons. So it need to remove 2 electrons because it is plus 2, so electrons 10. Similarly, sodium, how many electrons? 10. Oxygen, how many electrons? 10. So such a similar electronic configurations are known as what, children? Isoelectronic isoelectronic configurations. They are called isoelectronic configuration. Now you see that there are isoelectronic configuration. Here 10 electrons, 10 electrons, 10 electrons, 10 electrons. They all have the same number of electrons. Who has the greatest attraction for this 10 electron? This plus 12, because he has the highest number of protons. So therefore this 10 electrons more strongly attract this way. Next one is this, right? Next one is 9, next one is 8. So the smallest cation here, smallest ion is magnesium. So the answer should be what, children? Answer should be the magnesium. I guess that is clear to you. Then I go the next question of the same year. They ask first five ionization energies in kilojoules moles of an element are shown like this. See that these are the successive ionization energies of that particular element. First, second, third, fourth, fifth, sixth and seventh ionization energies are there. See the first one, 1010. Second one, 1900. Here 2900. Here 4900. Here 6900. Here 21300. See there's a very big gap. There's a very big gap in between 6000 to 21,000, very big gap. So these electrons require little energy to travel out, right? So then if the electrons are very close to the nucleus, very difficult to remove out. If the electrons are far away from the nucleus, easy to remove. So how many electrons are easily removed? This one easily removed, second one easily removed, third one easily removed, fourth one, fifth one easily removed. That means children, 5 electrons are easily removed. That means children, there should be 5 electrons in the outermost, 2, 3, 4 and 5. Okay, so that means how many electrons are there in the outermost energy level of this particular element? 1, 2, 3, 4 and 5. Why I said that? Because the biggest gap can be seen after removing 5 electrons. So 5 electrons in the outermost energy level, so that means it should be in the group 5. So I guess that's clear to you.